Hello, and welcome to Chapter 4, Section 2. Today we are trying to estimate areas under curves. So if you were like to graph something out and then find the area under it to up until like the x-axis, that's what we're trying to do today. So we're using something called Riemann sums. Riemann sums is basically someone who decided let's use rectangles to fit rectangles underneath the curves as best as possible and then use the areas of rectangles to then estimate that area. Because if it's a curve, it's really hard. There's not really like an area formula we could use, but if we can fit a bunch of rectangles under it, the rectangles themselves, the area of a rectangle is really easy to find. So if we just found the areas of all the rectangles and then added them up, then we could estimate that area under the curve as best as possible. So that is our goal today. So for our first example, we're going to use this curve f of x equals negative x squared plus 5, and then we're going to look at the area from x values of 0 to 2 using 4 rectangles to estimate that area under the curve. So first, I want to give you a visual a little bit so that we can kind of see like what we're actually trying to find. Okay, so here's the graph of f of x, negative x squared plus 5. So negative x squared is a upside down parabola, plus 5 means it's shifted up to the 5. And so here's my graph. We are trying to find the area under this curve between x values of 0 and 2. So really we're looking at like this section right here that I'm shading. We want to know what that area is, but it's like a weird shape because, you know, the top of it is curved. Obviously the bottom of it, it's, you know, separated by the x-axis and the y-axis, but that curved part is really what's going to kind of trip us up for finding that area. All right, so instead of like just finding that straight up area, because I don't know how I would do that, I'm going to use the Riemann sums and rectangles to kind of estimate that area. So when I say using 4 rectangles, then if I'm looking at x values between 0 to 2, splitting that up into 4 rectangles, we want those 4 rectangles to be the same width. So I could draw rectangles like this, but then the top of the rectangle, that's where I kind of have to adjust a little bit, because we can draw in rectangles like this, where the tip or like the top of each rectangle is basically where the endpoint is on the right side of the curve. So like having split up my 0 to 2 interval into 4 rectangles, I'm also looking at x values of 0.5, 1, 1.5, and 2. So the height at x equals 0.5, this point right here, is basically the height of that first rectangle. And then the y value when x equals 1 is making up the height of the second rectangle. And the y value when x equals 1.5 is the height of that rectangle, and so on. So when I know the height of each rectangle, then I can find the area of each rectangle and then add them all up. And that would give me like an estimation of that total area underneath the curve. Now over here on the right side, you can see this is another way to fit 4 rectangles to estimate the area under the curve of our function negative x squared plus 5. But as you can see here, all of my rectangles actually go above the curve a little bit, so this is actually going to overestimate the area that I want, while the one on the left underestimates the area that I want because there's still gaps where the area under the curve isn't covered by the rectangles. So these two, the way that these are set up, so the 2 different setups for these rectangles have different names. See how on this first one, the heights of each of the rectangles are made using the endpoints of the right side of each rectangle. So in this first rectangle, the height is the same as the height of the right side, like this point right here. And then this next rectangle is made with the height on the right side of this rectangle where it meets the curve. Same thing here and here. But then with the left Riemann sum, it's made with the left endpoint of each rectangle. So here's my first rectangle, the left side, where the point is on the graph is on whatever's on the left. And then here as the height, here, here, and so on. So for each of these, finding the areas of each of these, they're going to slightly differ because of the underestimation and the overestimation, but we want to be able to find these numbers and like the actual area mathematically. So if you remember, the area of each rectangle is going to be the length times the width. So then we need to figure out for each rectangle, the width should be exactly the same because it's the same width all the way across. For each of, whether we do the right Riemann sum here or the left Riemann sum, because we are looking at an interval from 0 to 2 and using 4 rectangles, then the distance between it is 2. Splitting it into 4 sections means that each width for each rectangle is going to be half, or 0.5. And then if we're looking at the right Riemann sum first, then the length of each rectangle is going to be how tall it is up until the point on the curve. So like for the first rectangle, the length of the rectangle is going to be when x equals 0.5, the y value at x equals 0.5. So if you want to think about each area as y, the value of y, times 0.5. And the value of y changes depending on which rectangle that you're talking about. So like this first rectangle, the y value is going to occur when x equals 0.5. Then for the second rectangle, the y value is going to be when x equals 1, x equals 1.5, x equals 2. So if we know the equation and we know what x values we're using, we can just plug them in to find the y value at each of those locations. So I've gone ahead and made a little xy chart so that I can see when x equals 0.5, the y value or the height of this rectangle is going to be 4.75. And when x equals 1, the height of that rectangle is going to be 4, and so on. So now that we know the height of each of the rectangles, then to find the area of each of the rectangles, we can just multiply the height with the width of each of our rectangles, which was 0.5. So 4.75 times 0.5 is going to be 2.375. When x equals 1, the height is 4. Then we get an area of 2 for that second rectangle. The third rectangle is going to have an area of 1.375, and then 0.5 for that last one. Okay, so we found the areas of each of those rectangles. Now to find the total area of the right Riemann sum, we just have to add all these areas up. So I end up with a total area of 6.25. So we're estimating using a right Riemann sum that the total area under this curve is 6.25. So now I'm going to do the same thing this time with the left Riemann sum. So we're still looking for each area. So we're looking for the height times the width, and the width is going to be exactly the same here because we still have 4 rectangles from points 0 to 2. So if our width is exactly the same, then really our heights are what's going to change because now we're using the left endpoints. So doing it this way, the x values that we're going to use are actually 0, 0.5, 1, and 1.5. So notice how there's always going to be one number that doesn't get used. So starting from 0 going to 2, like for a right Riemann sum, we don't use 0 as an x value. And then when we're talking about the left Riemann sum, we don't use 2 as an x value. So one of them is always going to get left out. Okay, so then same thing here. Find the y value by plugging in your x values into the original equation. And when we do that, I end up with 5, 4.75, 4, and 2.75. Okay, so once we have our y values, those are our heights, or if you want to think about it, the length of each rectangle. So next we want to find the area of each rectangle by multiplying it by 0.5, because that was the width of each rectangle. So I get 2.5, 2.375, 2, and 1.375. So this time when I add everything together, I end up with 8.25. So again, now that we have our two areas, notice how with our left Riemann sum, our rectangles actually end up going over the curve. So when we find the total area, the areas of each of these rectangles is actually a little bit over what the area under this curve should be. So that's why this number is a lot bigger than our right Riemann sum, because our right Riemann sum, there's some gaps in here that actually aren't covered by the rectangles, so we don't get the full area of under the curve. So the interesting thing about this is it's not always overestimating and underestimating the same way each time. So if your graph, the original function, if it's actually an increasing function, then the roles are reversed. When it's a right Riemann sum and the graph is increasing instead of decreasing like we are here, for a right Riemann sum, it'll actually overestimate, and for a left Riemann sum, it'll actually underestimate because of the way that the curve goes. So it's kind of neat that way. There's one more type of rectangles that we can use that will more appropriately measure this out or estimate that area under the curve, because right now we are overestimating here. So we want to be like, if we could kind of average this out a little bit, kind of meet in the middle, then it would be a better estimator. So it's still considered a Riemann sum, just instead of using right or left endpoints, we actually use a midpoint. All right, so here's a picture of the Riemann sum made with midpoints. So as you can see, we still have the same width of each of the rectangles because it's still 4 rectangles between our x values of 0 to 2, but then the height is actually made with the midpoint. So for the first rectangle between 0 and 0.5, then the midpoint between there would be 0.25. So we're basically looking at the height of each rectangle when x equals 0.25, we're seeing what height that is, and then when x equals 0.75, because that's what's in between 0.5 and 1, and using the height there, and then between 1 and 1.5, we're looking at the midpoint of 1.25 and seeing what the height is there, and so on. So I'm going to set up my xy chart again. So to find my heights of each of these rectangles, these are the x values that I'm using, so those are all the midpoints. And then plugging into my original equation of negative x squared plus 5, I end up with, first one is 4.9375, 4.4375, 3.4375, and 1.9375. Okay, so we have all the heights, so now we just need to find the area of each rectangle by multiplying it by the width, and the width is still 0.5. So we get more decimals. And then we can add up each of our rectangles. And that actually gives us a number in between the two areas we got before. This time my total area is 7.375. So even just based on the picture, you can see that it's going to be a lot more accurate because the amount of space that's under the curve and the amount of space that's kind of over for each rectangle, they look similar. So this is going to be a lot closer to our actual answer than either our left or right Riemann sums. All right, that's it. So you're ready to go out and for any function, any interval of numbers, however many rectangles you want are given, you should be able to calculate and estimate that area under the curve. Thanks for watching. Don't forget to like and subscribe. Bye.